today is our last new lesson on a new concept, and it is very much related to what we talked about last week with the distributive property of multiplication. Only this time we are distributing or giving out equally to all the terms division instead of giving out multiplication. So, everybody have your key points in front of you? Let's do this. First, a refresher. Everybody needs to remember that a fraction bar represents what operation? It represents division. Think about a fraction bar. It's a bar, and on top of it there's a number that goes right there, and on the bottom there's another number that goes right there. What does that look like right there to you? A giant division sign. So anytime you see a fraction, you can say over, like you're talking about a fraction, but you can also say divided by, because that's what it really represents. The first type of distributive property of division we're going to look at is the distributive property of division over addition. You can distribute your division over both addition and subtraction. We're going to start by modeling the addition. So down here we have 10x plus 20, all of that divided by 5. So we are equally distributing or giving out our divided by 5 to every term in the expression. Here's one term, here's a second term. We can rewrite this as 10x divided by 5 plus 20 divided by 5. We are giving out that divided by 5 to both terms in our expression. And this plus sign right here comes from the plus sign right there. So then we can simplify our expression. 10 divided by 5 is 2. We still need to keep the x there because we don't know if we can divide x by 5. So this simplifies to 2x. Keeping our plus sign. 20 divided by 5 is 4. So this simplifies to 2x plus 4. Let's try another one. I'm going to divide evenly across all my terms. Everything will get divided by 4. So 12x is getting divided by 4 plus 16y is getting divided by 4 plus 4 is getting divided by 4. Equally distributing my divided by 4 to every term. 12 divided by 4 is 3. I have to keep my x because I don't know if I can divide that by 4. Keep my plus sign. 16 divided by 4 is 4. Keep my y. Plus 4 divided by 4 is a very fancy 1. I cannot combine any more of my terms there. So this is my final simplified answer. Next up, just like we can distribute over addition problems, we can also distribute over subtraction problems. And it's the same deal. We are going to divide these terms, we are going to divide these terms, and there will be a subtraction sign in the middle. 3x divided by 3 minus 15 divided by 3 leaves you with 1x, and I don't need to write the numeric coefficient of 1 because I can count right there that that is 1x, minus 5. Final answer right there. This I can rewrite as 40x divided by 4 minus 5 divided by 4. So not every time will you get a nice even number. 40x divided by 4 is 10x. But 5 divided by 4 would either give me 1 whole and 1/4. It could also be written as 1 and 25/100. Or, since 5/4 is a simplified improper fraction, I could still just say 10x minus 5/4. That's a perfectly acceptable answer. This is a perfectly acceptable answer. And this is a perfectly acceptable answer. Whichever way you like. I happen to like this way best because so long as I can check and make sure that it's as simplified as it can be, I don't have to do anything. And then if I don't do anything, there's less of a chance that I might make a mistake when trying to convert to a mixed number or to a decimal. Key point number 4, when you use the distributive property, you're not changing the value of your expression, you're just creating an equivalent expression. That means that it might look different, but it still represents the same amount. Just like if you have an ice cream cone or an ice cream with a cone on top, all sitting in a cup. You still get the same amount of ice cream, you still get your cone, it just looks a little bit different. We are just changing it to make it simpler for us to understand and eventually evaluate, but we're not actually changing the amount that the expression represents. What I would like for you to do now is take the next 6 minutes with a partner to try these problems in your notes. Try to simplify your expressions. Some of them will include distributing with division. Some of them will include just simplifying. Some of them will include distributing with multiplication. All of them are excellent practice for our exam on Friday, so take the next 6 minutes. We'll pause the video. You try these problems, and then you can turn the video back on to check your work. Alright, at this point you should be done with your problems. We are going to quickly review the answers. For the first problem, we should have simplified to 7x plus y. That's because you are distributing your divided by 2 to each of the terms and keeping your plus. For the next one, we should have 2m plus 10. The third one should give you a final answer of y, because you have 4 positive y's and 3 negative y's. That means positive team wins, but only by 1 point. You do not need a numeric coefficient of a 1. I can count that that's 1y, and that's enough for me. Moving on, I should have x. Again, same deal. This is a fancy one. I don't need to write a numeric coefficient of 1. 100 divided by 100 is 1x, and I can just write the letter x, plus 3x becomes 4x. That is your final answer. Next up, this one is a little bit more because not only do you have a distributive property of division, but then you have to simplify terms after that. 12k divided by 3 is 4k. Minus 6 divided by 3 is 2. Plus 3k. I can combine my 2k's. They're both positive to make 7k minus 2 as a final answer. Next one, you also have a bit of work to do. Do you do addition or multiplication first? Well, according to order of operations, you do multiplication. I'll draw my box. 3, 5, positive 2x. 3 times 5 is 15. 3 times positive 2x is positive 6x. So if I rewrote, I'd have negative 10x plus 15 plus 6x. Combining my like terms, negative 10x's and 6 positive x's leaves me with negative 4x's and 15. Next up, we should have y, because 4 divided by 4 is 1, plus 6/4. I can leave as 6/4, I can leave it as a fraction, but this is not the most simplified fraction, and you know that you always have to simplify down as much as you can. So if you have y plus 6/4, you have the right idea, but you need to keep simplifying. 6/4 can both be divided by 2 to give you 3/2, which is the most simplified, and I know that right away just because I know that 3 and 2 are both prime numbers. But I also could have checked and seen, oh, they don't have any common factors except for 1. So your final answer here should be y plus 3/2. This next one, we don't have any distribution, no multiplication, no division, but we are going to simplify our like terms. 2m and negative 2m together make 0m's. Negative 2p and positive 5, neither of those can be combined, so your answer should be negative 2p plus 5. Or if you rewrote it, it could also be 5 minus 2p, or plus a negative 2p. But this is my preferred way to read it. 2 more. 26 divided by 2 is 13. Negative 12 divided by 2 is negative 6. Don't forget that x. Your answer here should be 13 minus 6x. And this last one, don't overthink it. This is a common type of problem to see, and some people just get a little confused by it. Here I have 1h, 2h's, 3h's, 4h's, 5h's. This is 5h. That's it. There are no exponents in this one. That does seem to be a common mistake. If they were multiplied together, then yes, there would definitely be exponents. It would be h to the 5th power. But that is not the case for addition. In addition, I just add them up. I have 5 h's. This is how I write it. 5 times h means 5 groups of h. 1, 2, 3, 4, 5, all combined together, which is another way of saying all added together. There you have it. All right, that's it for your key points for today on the distributive property of division.